Okay, so this is lesson 3 in organic chemistry, and today we're going to talk about substituted hydrocarbons. So remember last lesson we said a hydrocarbon is a chain that is made up of hydrogens and carbons. And substituted hydrocarbon means we're going to take one of those H's off the chain and we're going to replace it with something else. We're either going to replace it with a halogen, either chlorine, fluorine, bromine, or iodine, or we're going to replace it with a carbon group. So for example here, you see that a methyl group, methyl means one carbon, so we can replace it with one carbon, which has 3 H's on it, and right here on the bottom is where it would attach to the chain. Or we can add an ethyl group. Ethyl, the prefix 2, means 2 carbons, and its associated hydrogens, and we can add that to the chain. Or technically, we could add a propyl group, which would be 3. And as I said earlier, we could add chlorine, fluorine, bromine, or iodine. So let's take a look and see what that looks like. So in this top example here, you can see that I took methane, which is CH4, and I took off one of the H's and I replaced it with a Cl. So I simply name the group that I replaced it with. So I replaced it with a chlorine, and if you look in table R, Cl, the prefix is chloro. So this is actually chloromethane. In the one to the right, I actually put 2 Cl's on it. So I have 2 C's, so we use the prefix di for 2. So this is 2-chloromethane. And just so we can review, meth means one carbon, ane means all single bonds, and I'm just telling you what I've added. In the next example, I have 2 carbons, so that's F, all single bonds means it's an alkane, so it's ethane, and I have a fluorine on the first carbon, so this is just fluoroethane. Now, in the next example on the right, notice how I have 2 fluorines coming off the first carbon. So in this case, I have to give the address. So these are both on the first carbon, so we say 1, 1, which gives us the location of both of the fluorines. In the next example, I have 1 fluorine coming off the first carbon, 1 coming off the second carbon. So this is 1, 2, difluoro, meaning 2 fluorines, but one's on the first carbon, one's on the second carbon, ethane. And in the last example, I'm using bromine, and I got a little carried away here because I've got 2 bromines and I've got a fluorine. So I have 1 bromine on the first, on the first carbon along with a fluorine, and I have a second bromine on the second carbon. So now remember, I've got to number this one right to left so that my groups have the lowest number. Since I have 2 add-ons on that first carbon, that's got to be number 1. So that's 1 fluoro and then 1, 2 dibromo, and it's still ethane. All right, let's look at the last 4 examples. I'm going to number this one from right to left, 1, 2, 3. So I've got 1, 2 dichloro, and it's propane because it's 3 carbons and they're all single bonds. On this one, I have 1, 2, 3. I have chlorines in the first and third position, so it's 1, 3 dichloro. And now in this last one, I've added an entire group. I've added a CH3, which is my methyl, and I added it to the second carbon. It doesn't matter whether I number it left to right or right to left. This is 2-methyl, and it's still propane because the parent chain is 3 carbons. On this last one, it's kind of hard to tell which way I should number it. Let's see, I could go 1, 2, 3, 4. I have a methyl group here and a methyl group here. So I do need to number this one right to left, otherwise it would be 1, 2, 3. So this is going to be 2, 2. They're both on the second carbon. I have 2 methyls, so it has to be dimethyl, and the parent chain is 4 carbons, which is the prefix but, and it's all single bonds, so it's butane. Okay, so how did those atoms get substituted onto the molecule? It happened through a reaction process. Now I'm going to tell you what an addition and substitution reaction is, but you're not actually going to be tested on it until the second half of this unit. So let's start with substitution. You ever go to a restaurant and your meal comes with peas and you don't like peas, so you say to the waitress, "Can I substitute the peas for carrots?" She says, "Sure." Well, you had to give up something to get something, and that's exactly what a substitution reaction is. I'm starting with an alkane, meaning all my single bond sites are full, as with ethane, and I'm going to try to add fluorine gas. Well, I can't add fluorine because there's no room for it to be added. I can add the fluorine, though, if I take off a couple of hydrogens. So it doesn't matter which 2 I take off. You can see I substituted 2 hydrogens, and then I was able to add the fluorines. And I added them to the first carbon here, so that's 1, 1. Difluoro means 2 fluorines, and it's ethane because it's 2 carbons and it's all single bonds. And I formed hydrogen gas. I could have put 1 fluorine on another carbon, so I could have got 1, 2 difluoro. And actually, I want to show you one more thing, which is what the Regents usually does. I could have just substituted 1 of the fluorines. So let's say I just put 1 of the fluorines on, and I left the rest as H's. That would mean that that H that I took off would hook up with the other fluorine. So here I would have 1 fluoroethane and hydrofluoric acid in this case. So that's a single substitution as opposed to what I originally showed you, a double substitution. In an addition reaction, it sounds exactly what we're talking about. In an addition reaction, we simply add everything. And in order to do an addition reaction, you have to start with either a double or a triple bond. Because what you're going to do is you're going to take that double bond and you're going to break it, and you're going to make it all single bonds. And what that does, as you can see here, it opens up bond sites. It opens up bond sites right here on the bottom of those C's, in which case we can add the F's right in. So both F's were added to the bottom of the ethene molecule, and it becomes 1,2-difluoroethane. Okay, so here we're looking at this again. You've got ethene, we're adding the fluorine gas. We're going to break the double bond, make single bonds, and add it all. So if I were to summarize addition and substitution, side by side. So we have substitution. We're going to start with an alkane, and we're going to form normally 2 products. I know that I showed you a double substitution, but I also showed you a single. The Regents only does single substitutions. In addition, we're going to start with an alkene or alkyne, meaning something with a double or triple bond, and then we're going to change it to single bonds, and we wind up with only 1 product. Okay, and aromatic hydrocarbons, you won't be tested on these either in my class or on the Regents. They're basically hydrocarbons that form rings. They're called cyclic hydrocarbons, and they possess a bonding phenomenon called resonance, meaning that they can look different, but they're actually the way we draw them can be drawn differently, but they're actually the same molecule, and you'll learn about that in the next level class. Benzene, you can see, is C6H6. It has 6 carbons, 6 hydrogens with alternating double bonds. And there's some other examples there: toluene, paradichlorobenzene, phenol, and some others. But again, you don't have to know about aromatic hydrocarbons for the exam. All right, do the homework for this section, check it, and then move on to lesson 4.